Probability, chapter 13 of class 12 mathematics. Conditional probability. The probability of an event E is called the conditional probability of E given that F has already occurred and is denoted by P E slash F. Also P E slash F is equal to probability of E intersection F upon probability of F, comma probability of F is not equal to 0. There are some certain properties that 0 less than or equal to probability of E by F is less than or equal to 1. Second is probability of E dash upon F equal to 1 minus probability of E upon F. Second property is probability of E union F divided by G equal to probability of E by G plus probability of F by G minus probability of E intersection upon G. Probability of E intersection F equal to probability of E into probability of F by E into probability of E not equal to 0. And probability of F intersection is probability of F dot probability of E by F provided P probability of F not equal to 0. Independent event. If E and F are independent event, then probability of E intersection F is probability of E into probability of F, and probability of E minus F equal to probability of E dot where probability of F not equal to 0, and probability of F minus E equal to probability of F where probability of E not equal to 0. And if A, B, C are mutually independent events, then probability of A intersection B is probability of A into probability of B. Probability of A intersection C is probability of A into probability of C. Probability of B intersection is probability of B into probability of C. Probability of A intersection B intersection C is equal to probability of A dot probability of B dot probability of C. Theorem of total probability. Let E1, E2 dot En be the partition of sample space S, and suppose that each of E1, E2 dot En has a non-zero probability. Then let A be any event associated with the sample space S, then probability of A is equal to probability of E1 dot probability of A upon E1 plus probability of E2 dot probability of A upon E2 plus dot probability of En dot probability of A upon En. Or in short term we can say probability of E I by A is equal to sigma I equal to 1 to n probability of Ei dot probability of A upon Ei. Probability distributions. The probability distribution of a random variable x is the system of numbers x, that is x1, x2 dot xn. Then probability of x is p1, p2 dot pn, where pi is greater than 0. Then it is called sigma I equal to 1 to n pi, where is equal to 1, where I equal to 1 to dot n. What is called Bayes theorem. If E1, E2 dot En are events which constitutes a partition of sample space S, that is E1, E2 dot En are pairwise disjoint, and E1 union E2 union dot union En equal to sample space S, and AB any event with non-zero probability, then probability of E I upon A equal to probability of Ei dot probability of A upon Ei whole upon sigma I equal to n probability of Ei dot probability of A upon Ei n equal to 1 2 3 dot n. Mean of a random variable. Let x be a random variable whose possible values x1, x2 dot xn occur with probabilities p1, p2 dot pn respectively. Then mean of x is mu, and mu equal to sigma I equal to 1 to n xi pi. It is also called the expectation of x denoted by E bracket x. What is called a random variable. Random variable is a real valued function whose domain is the sample space of a random experiment. Okay, so this is all about the probability and the completion of chapter 12 mathematics.